In this video, we are going to see about the concept of Ethernet. I'm Ms.K.Mahalakshmi, working as a lecturer in the Department of Computer Science, Sita Lakshmi Ramaswamy College, Trishrapalli. Now, what is Ethernet? So, Ethernet is a network technology invented to connect network devices together. It is commonly used in wired local area networks and it is referred to as the IEEE 802.3 protocol. And this protocol has evolved and improved over time to transfer data at a speed of more than a gigabit per second. This is what is illustration of or picturization of Ethernet. Now, Ethernet was created in 1973 by a team at the Xerox Corporation's Palo Alto Research Center in California. So, Ethernet was created by Robert Metcalfe. So Robert Metcalfe was inspired by the idea of Aloha network for creating Ethernet. So this is what is a representation of Aloha network. So now coming to the timeline of Ethernet. So in 1973, first version of Ethernet called Standard Ethernet developed mainly for LAN communication. In 1995, advanced version of Ethernet was released. It was called as Fast Ethernet. In 1998, much faster standard gigabit Ethernet was released. In 2002, 10 times faster version was created and it is called as 10 gigabit Ethernet. In 2014, 2.5G base T and 5G base T was developed. It was created with low speed on purpose because 10 gigabit Ethernet was not supported in many devices and people cannot afford to install such standard. In 2016, new high-grade Ethernet 25 and 50 gigabit Ethernet was released and approved. Then 40 gigabit and 100 gigabit Ethernet was developed as advanced technology in terms of speed. Now 1 terabit Ethernet used in data centers, Facebook, Yahoo, Google and many large organizations. So Ethernet is widely used technology and almost used in everywhere. Now what are the components of Ethernet? So there are three main components. Number one, Ethernet cards or adapters. Number two, Ethernet cables. Number three, Ethernet routers or hubs. Ethernet cards or adapters. As you can see on the right hand side, this is what is the Ethernet card. So it is actually installed in each computer that connects the network through an Ethernet cable. An Ethernet cable is represented below. Next is the Ethernet cables. So Ethernet cables contain several wires which allow the transfer of data in both directions to and from the computer. They can come in a number of styles, the most common being category 5 and category 6 cables. Now, types of Ethernet cables. So there are three types of Ethernet cables. One is coaxial cabling, twisted path cabling, and fiber optic cabling. Coaxial cabling. So as you can see on your right hand side, this is what is a coaxial cabling. So it is surrounded by a layer of insulation. This cable is not affected by outside interference. Maximum transfer rate of around 10 Mbps. Nowadays they have been replaced by twisting cabling. Moving on to the twisted path cabling. So this type of cable has 4 pairs of wires. The wires are twisted together to keep outside interference to a minimum, and this type of wiring can be found in LANs. Fiber optic cabling. As you can see, this is what is a fiber optic. These cables make use of optic fibers to transmit data. The data transfer is in the form of light. Within the cable, there are glass strands that are covered by cladding. It is very fast but quite expensive. Next is the categories of Ethernet cabling. So Ethernet cable category types, you can see there is right from category 3, 5, 5E, 6, 6A, 7 and 8. Now what is category 3? So this is released in 1990s. This cable may have 2, 3 or 4 copper pairs. It is capable of working with networks having frequencies of up to 16 MHz. It was mainly used with 10 Mbps Ethernet networks. Category 5. So this is arrived in mid-1990s and has a maximum transfer speed of 100 Mbps. It can transfer data up to distance of 100 meters. It was a standard Ethernet for Ethernet cables for a long time. However, currently it is obsolete. Category 5E, it has speed up to 125 Mbps and higher frequency specifications as well. Physically, it is quite similar to Cat 5. So next is category 6. So this offers much higher bandwidth and data transfer rates. It can achieve speeds up to 1 Gbps over a distance of 100 meter. Next, category 6A. So this support higher speeds and bandwidth, but it is not flexible as Cat6. Category 7. It allows for a maximum data transfer rate of around 10 Gbps and a bandwidth of 600 MHz. Category 8. So these cables are more expensive than Cat7 or the Cat6A, but much more capable. They support a data speed of 40 Gbps. Ethernet routers or hubs. So a hub is often used as a common connection point for a device in a data network. So an Ethernet hub contains multiple ports. So when a packet arrives at one port, it is copied to the other ports so that all segments of the local area network. So next is the Ethernet protocol. So the most popular and oldest LAN technology is Ethernet protocol. Computer Society of India set a standard called IEEE, which is Institute of Electrical and Electronic Engineers. They created a project called Project 802. So the Ethernet protocol uses a star topology or bus topology, as you can see in this figure. The main reason to use Ethernet widely is it is simple to understand, maintain, implement, provides flexibility, and permits less cost in network implementation. Now coming to the Ethernet protocol architecture. So in the OSI network model, Ethernet protocol operates at the first two layers like the physical and the data link layers. But Ethernet separates the data link layer into two different layers called the logical link control layer and the medium access control layer. So this is what is a representation. As you can see, this OSI is divided into physical layer and data link layer, whereas Ethernet, this physical layer remains the same, whereas data link layer is divided into logical link control and medium access control. So the physical layer in the network mainly focuses on the elements of hardware like repeaters, cables, and network interface cards, whereas the data link layer in the network system mainly addresses the way that the data packets are transmitted from one type of node to the another. Ethernet uses an access method called CSMA or CD, which stands for Carrier Sense Multiple Access or Collision Detection. So Ethernet is available in different forms where the current Ethernet can be defined through IEEE 802.3 standard. The speed versions of Ethernet are available in three different types: 10 Mbps called standard Ethernet, 100 Mbps called fast Ethernet, and 1000 Mbps called as gigabit Ethernet, whereas Mbps stands for millions of bits for each second. Now this is what is a protocol frame structure for Ethernet, because as you can see, preamble occupies 7 bytes, SFD occupies 1 byte, destination address occupies 6 bytes, source addresses occupy 6 bytes, length of 2 bytes, data 46 to 1500 bytes, and CRC is for 4 bytes. What is preamble? So Ethernet frame starts with 7-byte preamble. This is a pattern of alternative zeros and ones which indicates starting of the frame in which the allow sender and the receiver to establish the bit synchronization. SFD is your starter frame delimiter. So this 1-byte field is always set to 10101011. So the destination address is the next set of bits that will begin the frame as indicated by SFD. So next is the destination address. So this 6-byte element contains the MAC address of the device for which the data is intended. Next is the source address. This is also a 6-byte element which contains the source machine's MAC address. So since source address is always a unique address and it is unicast, 0 is always the least significant bit of the first byte. Length. So it is a 2-byte field which indicates the length of the entire Ethernet frame. This 16-bit field can hold the length value between 0 to 65534. And data, this is a place where actual data is inserted, is also known as payload. Both IP header and the data will be inserted here if the Internet protocol is used over the Ethernet. Now coming to the CRC, which is the cyclic redundancy check. So it is a field of 4 bytes. The data is used in this field is a 32-bit hash code created using the fields for the destination address, source address, length, and data. So data is damaged if the checksum is calculated by the destination differs from the checksum value supplied. Now moving on to the Ethernet address. So it can be unicast, broadcast, multicast. So here the cast refers to how many people or devices we send the data to. Coming to unicast, so it refers to one-to-one sender. One-to-one sender sends the data to only one device. Multicast, it refers to one-to-many or many-to-many sender sends the data to many devices. Broadcast, it refers to one-to-all in which sender sends the data to all devices. Thank you.